Hey gang, we're going to get started on the different kinds of fire protection systems, and this week we're going to look at fire alarms. We're actually going to take 2 weeks to talk about fire alarms because they are kind of complicated. There's a lot of different kinds out there. So this week we're just going to talk about the basic components that you would find in almost any fire alarm system, from the very simple but also to the very complex. And then we're going to talk about some of the different functions. Next week we'll talk about the different types of systems and how they work with the other fire protection systems. So let's get started. Our learning objectives this week is you need to list and describe the 3 types of fire alarm signals. Then we're going to talk about the functions of a fire alarm control panel, which we kind of refer to as the brains of the system. Everything kind of gets controlled by the circuitry in the fire alarm control panel, or also fire alarm control unit. Both things mean the same thing. We're going to talk about annunciator panels, and we're going to list and describe the different components that make up a fire alarm system. Then there will be a quiz related to this week. There's also a little crossword puzzle having to do with fire alarms. So, we talked about, in talking about the history, that time has become something that we look at and realize we need to be faster getting out of the building, faster getting the fire department to the fire. So surviving a structure fire is really dependent on time. Fire alarm systems monitor the initiating devices that sense things like smoke, heat, the water turning on a sprinkler system, and all of these different types of monitoring devices, or what we call initiating devices. They send a message to the fire alarm control panel. That sends a message to the notification devices. They sound the alarm or the horn or the flashing lights, whatever it might be, and it's going to notify people, sometimes in less than 30 seconds, of smoke beginning to build up. So, a fire alarm control system might also provide operational control of other building systems. We'll talk about that later, but elevators in a high-rise building go to the ground floor as soon as the fire alarm goes off. It's also capable of signaling other locations to notify staff, or a monitoring station, or even straight to the fire department, depending on the way it's built. It can also perform other life safety functions. The fire alarm systems oftentimes will release exit door locks and all sorts of things. So we're going to look at all of that today. There are different types of fire alarm signals. Now, the fire alarm that goes off in all of the rooms is definitely a recognizable sound that we've all been exposed to. But not all the information that's communicated by the alarm system means that there's a fire. There are signals that can happen at the panel, and there'll be a beeping or a milder sound that doesn't activate in the whole building for 2 different kinds of signals that the fire alarm control panel can put off. A signal at the panel might indicate there's just a problem with the system. We get rain here every once in a while in Southern California, but water can sometimes get into the system, cause a short. And there can be other reasons why a short might happen, a defective device or whatever, and that will send a trouble signal to the fire alarm control panel. A red light will turn on, and a beep will start to go off. So it might be mistaken for alarm, and then people start calling the fire department. It's not an alarm, it's a trouble signal. There's one other kind of signal, and it's supervisory. So there's different types of signals that are generated by the fire alarm control system. And it can also indicate different levels of response. There are systems where it just puts off a message sending security to go check. So lots of different ways that the systems can work. And as we've gotten better with circuitry and computer chips, it's really getting even more and more intricate. So the alarm signal alerts occupants of a fire emergency. That's the main one. And occupants should immediately leave the building. And, in schools, you grew up, all of you, elementary school, junior high, high school, we'd have fire alarms, and to leave the building. Yeah, but you know what? You go to places like a hotel, fire alarm goes off, what do? They call the front desk. Hey, what's that sound? Can you turn that off? I'm trying to sleep up here. So a lot of times people aren't quick to obey the alarm signals, and they think it's a false alarm. This is especially true in college dormitories. There's a famous fire that happened at University of North Carolina, Chapel Hill, where most of the students stayed in their rooms when there was an alarm, because they were used to the alarm signal going off whenever anybody would burn the popcorn in the microwave. So yeah, a lot of those people got burned, and a couple have died. So you got to pay attention to those signals and those sounds. The signal's going to sound when some kind of initiating device, a pull station, smoke detector, water flow switch goes off. Now, water flow sometimes will only go to the monitoring company, and then they send the fire department to check it out. But sometimes it sounds throughout the whole building. So sometimes it'll even only go off on certain floors. But response should be immediate. People should take them seriously. Unfortunately, because of false alarms, we get a culture of, oh, it couldn't happen here, it won't happen to me. And people hesitate to leave when they should leave. So let's talk about those two other kinds of signals that I mentioned. Trouble signals sounds when there's that system integrity problem, like I mentioned. It can be a power problem, it can be a component problem, it can be a device removal. Sometimes that's going to set off a supervisory signal. We'll talk about that in a second. It can be a ground fault, it can be a break in wiring. Most of the time, like I mentioned, it's usually a moisture problem that causes the system to short, and it'll get this constant tone, beep, or buzz, and it's also going to have a red light that flashes on the fire alarm control panel and on the Annunciator panel, and that's telling the people who own the building or that maintain the building that there's a problem and you need to call the alarm company. Now, only the maintenance personnel who are trained to work with it should be called out. They should receive the notification. You don't need to call the fire department. It's not necessary. But we need to get somebody out to fix it. Typically, people will avoid these trouble signals because they don't want to spend the money to fix the system. I used to put schools all the time on fire watch, which meant they had to pay someone to walk around the school and make sure that the school wasn't on fire. And that was LA County's way of forcing them to fix the system when it was broken, because we don't know if the system's reliable when the trouble signal is going off. So we make them fix it by putting them on fire watch. They don't want to pay somebody to walk around and look at a building and go, yep, not on fire. And then walk to the next one. Yep, that one's not on fire too. And then they have to do that 24/7 until it's fixed. Yeah, that's a lot of money that's wasted down the drain. Why not just call the fire alarm company, get them out, get it fixed? The supervisory signal is similar to the trouble signal. It's not an alarm for everybody, but it's more of a notification that something's wrong, but in a different way. When the normal ready status of the other fire protection systems or devices have changed, that can lead to a supervisory signal. But it uses a constant tone of visible light to indicate a condition requires attention. Now, in this case, responder must investigate, and it can be security personnel, it can be somebody associated with the fire department or with the building, because usually what this is telling us is that someone or something is turning off part of the system. So the fire alarm panel is going to monitor the sprinkler system and the fire pumps. It's going to monitor air and water temperature. It's going to monitor water level and pressure and duct smoke detectors. So if you've ever seen an OS&Y, an outside stem and yoke, or outside, what's the other way of saying that? I forget. But an OS&Y, if somebody starts to turn that off, like an arsonist who wants to set the building on fire, if he starts closing it, you put a couple of turns into it, it's going to send a supervisory signal and let the alarm company know somebody's turned off the system. So it's more of a protection against, in fact, the other name for a lot of these supervisory devices is tamper device. Somebody's tampering with the system. So this isn't always because a short in the wiring or a device has just lived out its life and it's broken. This is more something's going on that's not right. And usually sometimes it's just as simple as the alarm company or the sprinkler companies out there working on it, and they forgot to call the alarm company and say, hey, we're going to shut down the system while we're doing some maintenance. They'll get this supervisory signal. So let's start talking about the main thing here, the components. There's 3 basic components associated with an alarm system. So all components require evaluation. They have to be tested for listing and approval with companies like UL and FM Factory Mutual. So these different companies, and sometimes even the state fire marshal or the NFPA will approve them, but the listing companies are companies that test them and put them into lists as these devices work. So some fire systems have very few components. It can be as simple as a manual pull and a bell. And of course, there's going to be some kind of connecting device between the manual pull and the bell. So that's really super simple, but sometimes they're super complex and a lot of interconnected components. Each component has a place and a purpose. So it's important to understand how they relate, how they work together. So I want you to kind of use this one, maybe write down in your notes, the main fire alarm system components. Number 1 is the fire alarm control unit or control panel. FACU or FACP refers to the same thing, just different companies use the 2 different words. Then there are initiating devices and notification appliances. I think you might have a test question on some of that somewhere. So let's talk about the brains, the fire alarm control panel or fire alarm control unit. It's that interface between all the components, and it's what's going to let the responders know and let the people know. People get out, fire department get to this location. So it monitors the integrity of the system, circuits, and devices, but it also processes any kind of manual or automatic signal from the initiating devices. It also can drive the notification appliances and interface to control or activate other systems in an emergency. So it provides power to support all the system devices as well. All those devices that have wire running back to the control panel, not only is that the way to communicate, but okay, sorry about that. My phone went off. I had to answer it. Let's just keep going. the fire alarm control panel is going to also provide power through those same wires that it uses to communicate with the devices. So here's a typical red fire alarm control panel. And usually they are red, but I'm going to show you one that's gray in a minute, in a second. No difference. They just usually paint the fire alarm ones red so it's easily identifiable. But sometimes you'll have systems that also do security and other stuff, and so they might be a different color. Most of the time, look like this, red. Now this one is a very complex one, has digital readouts, has input keys, all of those kind of things. And that's pretty much your typical fire alarm control panel from the outside. And as I said, here's a gray one, very similar, a few more buttons, a nice screen there, a little bit bigger screen. But now listen, we've got a couple of buttons that we push on this as fire personnel. We silence the alarm, and we can press the reset button, but we don't do any inputting. This is done by fire alarm technicians that work for the fire alarm company that provided this system. So all of those buttons, don't be intimidated by them. There's probably 3 buttons on the whole thing that as a firefighter you might push if you responded to a fire or if you were testing it. Even if I'm testing it, I don't push any of those buttons. I let the technician push it. You just don't want to have something weird go on. So I just don't touch them. Okay, so power sources. The fire alarm control panel will have to have dual power supply. So it's going to be tied into the electricity, and you have to have the bus or the circuit on the electric panel has to be marked that this is for the fire alarm control panel. It also has to have a little locking device on it where somebody can't just come up and turn it off, but it can still trip if it has a power surge, but it can't be turned off by somebody just walking up and turning it off. It has a little lock on it. So the power supply comes from the electric panel and it goes in. And again, only qualified service personnel need to access the power supply, but it has to have those 2 independent power sources. So now most of the time it's going to be battery backup, and I'll show you some pictures of that. But rechargeable storage batteries can be used, or just regular older batteries. The generators can also be used. And generators there might be multiples of them, but when we get into like really big buildings like high rise, instead of just using batteries to back up, they're going to have generators to back up all of the fire alarm control systems, the pumps and all of that. And there could be multiples in a row, there could be just 1 or 2, but you have to have a minimum of 4 hours of battery or backup capacity. So here's a typical inside the circuitry of a panel with a battery. And that's just a basic battery backup. Now that happens to be a power or an expander panel. This is not the main panel, but it's just the picture that I chose. So there are power expander panels and other panels that you might find that are part of the system that aren't the fire alarm control unit, but because maybe the system's so complex, they've got to have more circuitry. But again, they have to have power backup. And there are even going to be sometimes power expander panels. So when buildings are renovated, old control panels might not have necessary power capacity. So the modern day systems use a lot of current. So they might need a power expander. So, and it's also not always practical to place all the power in one panel. So they have these extra panels that you might see. How are you going to know the ones that's the fire alarm control panel? Well, it's easy. It's the one with all the buttons on it and the digital readout. So these power expander panels just provide supplemental power to support the devices. So here's a typical picture there on the left. 2 batteries. some circuitry. This is a power expander panel. If you look at the box on the right, that's an old school fire alarm control panel that doesn't have a digital readout, but just has little lights there. You can see the green, the red, the yellow. This is just a very basic system that tells you it's on, it's not on, and we're having an alarm or not having an alarm. So not as intricate and up to date. But you see a lot of these because a lot of systems were put in way back in the 50s, 60s, 70s, back in that other century where, most of you don't even, weren't born. But the different kinds of control panels that are older might just tell you there's an alarm. Doesn't tell you where it is. The ones that have the digital readout not only tell you which building, but which room and which device is going off. So old and new. Now, the other very important devices are the initiating devices. They work with the fire alarm control panel, and there's two different kinds of initiating devices, or two different types, manual or automatic. Now, the manual activation, obviously manual, requires a human. The automatic is initiated by some kind of event or what it senses. So just like with security, you have motion sensors. Somebody's just walking around in the room. It sees it, it senses it, it sends an alarm. With fire, we're usually going to be sensing smoke, heat, water flow, and things of that nature. Let's keep going. So manual initiating devices. They're almost all these manual pull stations. You've seen them. They're all around. A lot of times they're right near the exit. So they require a person to pull a handle to initiate alarm. Some of them require two motions. You've got to lift a box that covers it, then you pull the fire alarm down. Now, a lot of those, they have a little alarm right there at the box. So if somebody lifts the cover, this is for like places where maybe it's a con home where they have Alzheimer's patients. If somebody lifts up the cover, an alarm goes off, or at an elementary school. That way, if somebody's messing with the system, now, not an alarm in the building, just right there. Sometimes it's an obnoxious buzzer. So somebody goes to lift that thing and they get this, and they let go because that's a scary sound, and now everybody's looking at them. So you can't just walk up and pull the manual pull. Like I said before, manual pulls sometimes are the only device in the initiating device in the whole system. And that's in like little daycares or small offices and things of that sort, where you just have one device. It's got to be in a place where it's unobstructed, 3 feet in all directions from the center of the device. So nothing, sometimes they'll go, somebody's put some palm tree, fake palm tree in front of it, or a bunch of furniture in front of it, that they got to move it. It has to be in an obvious location, unobstructed, and normally, like I said before, within 5 feet of the exit door. So here's some pictures of different manual fire poles, and that one on the top right is the kind, like I was saying, when you lift on it, it puts off a buzzer. So the different systems, there might be a non-coded or a coded, and that means that it tells you, if it's coded, exactly which manual pull was pulled. If it's non-coded, all you know is there's been an alarm, a general alarm. Sometimes with manual pulls, there's a pre-signal to some devices, so there'll be an alarm right there, and then there's the big alarm after a certain amount of time. Some of them require you to break glass. Some of them take double action, lift, go down like we saw. But once pulled, you can't unpull it. It requires a resetting by some kind of a facilities personnel. Usually they have to have a special key, a wrench, or a screwdriver. The automatic initiating devices are our second type. Now, there are many different kinds of automatic initiating devices, and the first kind we're going to talk about is heat detectors. And they sense a temperature fluctuation. Now, there's fixed temperature heat detectors where it gets to a certain temperature, alarm goes off. And they're spot type and line type. So they sense the heat and they send a signal. The rate of rise detectors notice if it goes from one temperature to another temperature. So they might be used in a factory where you already have high temperatures, but if all of a sudden it goes up really fast from one temperature to another temperature, they might use the rate of rise. There's rate compensation detectors. They're not dependent on rates of temperature change. There's fixed temperature rate of rise heat detectors. Combine the characteristics of the two of them in one unit. So here's some pictures of different types of heat detectors. One of the ways to tell if you're looking at a heat detector versus a smoke detector, this isn't 100%, but it's usual. Notice very small holes. You don't need a larger vent to allow the smoke and the particles in on a heat device because it's just sensing the heat. So in our smoke detectors, we're going to have bigger vents. So notice the small vents. So there's different types of smoke detectors, and they're just based on how they work. In your book, you can read about this. I don't want to bore you with all the details about it, but there's the ionization smoke detection. There's photoelectric light scattering smoke detection. So if there's little lights in it and if there's something in the way, it scatters the light and then it senses that. Or light obscuration. So there's a light going from an initiator to a receiver in the device, and if particles get in between, they obscure it and it detects it. Then there's air sampling smoke detectors, and there's also duct smoke detectors. So the alarm verification validates the smoke condition before the fire alarm signal sounds. So here's two basic smoke detectors, and the one on the right looks probably like the one at your home. The one on the left is more of an industrial use. So there are some other kinds of automatic initiating devices out there. There's radiant energy detectors that look for flames, sparks, embers, that they detect light spectrum. There's gas sensing detectors that detect gases or vapors that are associated with fire or hydrocarbons, but you have a gas detector in your home, and if you don't, you should. It's a carbon monoxide detector. It's sensing gas. So water flow initiating devices are also an automatic device, and it's a switch that is in the pipe. And as in the riser of the pipe, as water moves, it pushes the paddle. It's a paddle that goes from down to up when the water flows through it. And it knocks off a switch, sends a message to the control panel. The alarm pressure switch is best suited for dry pipe, but a paddle is best for water flow. So here's two of the radiant light kind of detectors. Not very common, usually only in industrial use. So here's a little diagram about the differences between heat, smoke, and flame detectors. The heat detectors are a little slower to work, but there's very few unwanted alarms. The cost is low, but they're still not as common because of the slowness of it. Smoke detectors are a lot faster. You can get an initiation within 30 seconds of a fire starting to smolder in a trash can. Very fast. The amount of unwanted alarms is a little bit higher because of dust can set it off. It's just sensing particulates in the air. So that's why you should not have one in your kitchen. Don't put a smoke detector in your kitchen. You're going to get lots of false alarms. In a place where they produce a lot of dust, they might stay away from smoke detectors in some kind of a factory, and they might go with heat or flame. Flame is very fast, but you have a high probability of unwanted alarms, and they're extremely expensive. So, like I said, I've never seen one. So I've never actually been in the kind of factory that where they might use those. So they're very rare. They cost too much, but they're looking for deflagration or a high value hazard. So those are, it kind of helps to see that. So here's a little diagram of the line type heat detector and how it works. And it just has these little pneumatic line type heat detectors, sends a message to the FACU. That's an electric line type. And then there's line type heat detection that uses conveyors and cable trays. So a roller may, sense the change in temperature. This is in your book. You can read about it. Not as important to me. Just know that there's different kinds. Here's a little diagram about light scattering type smoke detectors. So see when the particulates come in, it scatters the light, and the sensor senses that instead of the light just going from one side to the other. And that's how, again, because it's sensing particulates in the air from the smoke, this can lead to false alarms because it could be dust, it could be even steam, it could be smoke from cooking in the kitchen. And then the light obscuration type is there's a sender of the light and a receiver of the light, and when the particulates get away, it sets off the smoke detector. These are used a lot in atriums where they want to catch the smoke right away. They don't want to wait until it gets all the way to the top floor. They want to see any smoke that's in the air from the bottom floor to the third floor. So atriums are where you have openings that go up between floors. So they oftentimes are going to use the light obscuration type. So let's move on to the last part, the last kind of appliance or device or component in our fire alarm system, and that's the notification appliances. So these are going to give audible, visible signals to prompt the evacuation of the occupants. So you're going to see lights flashing, those are there for the deaf, or you're going to hear horns or beeps or buzzers, and they also can report that there's a problem needing attention. A lot of our fire protection systems, we're going to see later on, a lot of the gas systems and foam systems and things like that, they're going to set off an alarm that says, hey, I'm about to turn on. And it gives personnel in the building enough time to shut it off if it really doesn't need to turn on. So the types of systems and installation depend on the code requirements and the NFPA standards. They can be simple, they can be complex, and it also, we've got to be compliant with ADA. So there's public mode and private mode. Public mode, general alarm is going to be sounded. In a hospital or in a prison, or in a place that has 24/7 security, there might be a private mode alarm where it's at a reduced volume or just at a specific location that's manned 24/7. And these are designed to avoid unnecessary movement of the occupants, like I said, hospitals, prisons, nursing homes. These alarms can be coded, non-coded, and even be textual signals. So the alarm system can provide the responders with especially in these new technical computer-operated systems, it can tell us what building number, what room number, and what device is causing the problem. In places where it doesn't give us a textual or a digital readout, there can be coded signals that just give a visual or audible pattern that we know that it's kind of like even Morse code or whatever that gives us, or maybe gives us just the building. Doesn't give us the room and the device, but it gives us the building. A non-coded signal just provides a constant visual or audible signal that alerts everybody. The textual signal may be a voice message over loudspeakers or a text message on the panel, like I said. In a high-rise building, there might be a computer-generated voice that tells people from floors 10 and above to go to the roof, floors 8 and the bottom, go down to the bottom floor. Hey, all of you on floor 9, you're in deep trouble. So, whatever, it's going to say, give specific messages. And that's pretty cool that it has that capacity. The different kinds of audible devices that are out there are quite diverse. There's horns, speakers, bells, chimes, buzzers, sirens, and like I said, there's even voice audible devices that can give specific instructions. Horns and horn strobes is probably the most common. They have to be 15 decibel above the ambient sound. So you've got to be able to hear it. A lot of times inspectors will take these devices that can tell you the amount of decibels just to be sure. But most of the time, you can just tell by listening to it, oh yeah, that's more than loud enough. So here's a bunch of pictures of different devices. The one on the top left is a horn only. Again, because of ADA, we just don't see those much anymore. Then you have in the middle a horn strobe. You can see the back workings of it there. Top right, a horn strobe. At bottom right, a horn strobe. And those are just different versions. But the bottom left, that's a more of a siren type. And, it just depends on what the code requires and what is best for the system. Those visible parts of the appliances are for the deaf. We have flashing lights. And the flashing lights, if you can see two at the same time, they have to be synchronized. So there's a computer chip that they add to the system to make sure that all of those lights are flashing at the same pace. Because when people who are subject to seizures, epileptics, and other conditions, strobe kind of flashing lights can set them into a seizure. So they have made it so they have to be synchronized. All the lights are flashing at exactly the same time at a certain pace. And so that's there for the hearing impaired occupants. The light intensity is measured in candelas, so it has to be bright enough to where you see it flashing. There are other devices for the deaf. There's even devices that will vibrate their bed when they're in bed. So at night, a strobe might not awaken them, but the vibrating bed will. There's also combination appliances, and like I said, horn strobe, speaker strobe, bell flashing. And there's a lot of advantages to those kind of systems. They're probably the most common nowadays. It gives you a visible signal, gives you that audible component, and gets people out of the building faster. So there's one other device that's not always required, but it's a lot of times people see an annunciator panel and they think it is the alarm panel. An annunciator panel is in larger facilities where they want the fire department to get the information from the fire alarm control panel without having to find it. Because usually the control panel is in a closet or in a power room, an electrical room, and hard to get to. They're supposed to have a sign on the door that tells you where it is. But just because in the larger facilities, excuse me, it can take a while to find the panel, they'll use these annunciator panels. So it'll be right near the front door, and again, in larger buildings, and it's a device that gives you most of the information that's in the control panel, but there's no control devices. So there's only a couple of buttons. There's the silence, there's the reset, and then there's lights that or digital readouts that'll tell you where the alarm is going off. So it's a graphic annunciator panel that can give you information and the zone, the device, what's going on. So here's the difference. Look at on the right, that's a fire alarm control panel, and from it you can control the whole system. You look at the one on the top left, this is much more minor, more minimal, and it just has some basic buttons to push to acknowledge it, to silence it, to reset it, and it tells you exactly what's going on. So just basic difference is easier to get to the annunciator panel. So as I said before, there are other components and systems associated with the fire alarm systems, and it monitors these other fire protection systems for normal status and for their integrity and or alarm conditions. So if the kitchen hood system goes off in the cafeteria, the whole school will get an alarm, and that it will tell the fire alarm control panel to set off the alarms. The electronic valve supervisory devices are, as I said before, a valve in the wrong position can set it off. The tamper switches can set it off as someone turns to close a device or to turn it off. The off normal signal sounds if valve is off normal position from 1/5 of the travel distance. So if you turn it off 1 or 2 turns and it takes like 5 turns to get there, it's 1 turn is going to turn on the supervisory switch. So there's a reset switch and to put it back into normal if all it was an accidental, messing with the system. There are other types of pressure switches. In a dry pipe sprinkler system, it doesn't have it's going to have a different sensor to open the valves to let the water flow. So you're going to get an alarm right away from that, from dry pipe, pre-act, and from pressure tank systems. If the pressure tank systems, if the low pressure continues or pressure exceeds, so they pressurize a dry pipe system with air. And so if the pressure starts going low, the supervisory device will say, hey, it's leaking air, and it's just saying we need maintenance to give some attention. Just a few more here. The air and water temperature sensors and water level sensors in rooms housing fire protection and water in storage tanks. If it's a dry pipe system, but it's been allowed to have, if it's a freezing condition area that would normally require a dry pipe, but they've allowed for wet pipe because there's adequate heating, well, it's going to monitor the temperature and tell them if the system is getting exposed to freezing temperatures or it's the water's freezing in a storage tank or whatever. So early warning that water could freeze and render the system useless. It can set off a supervisory signal. Or if the water level goes down. Those are some of the other things that it can do just to help keep the integrity of all the systems, not just the fire alarm. So, in summary, our fire alarm systems notify our occupants to get out. It notifies the first responders to get there, and it signals other fire protection systems and other building systems. Can even turn off the heating and air conditioning. It can turn off the electricity or the gas. Lots of different things that a fire alarm control system can do. And it can provide that important information. So when we have a fire where we don't have maybe we have smoke showing, but we don't have fire showing, we'll go to that alarm and get information to help us find where the smoke's coming from. And then, as I said, there's 3 types of fire alarm signals: the alarm, the supervisory, the trouble. And, timing is critical. So that's why we need these fire alarm systems. Hey, thanks for listening. Sorry this was a little longer than I hoped it would be, but I hope it was informational to you. Alarm systems are very complicated. It is the biggest NFPA standard notebook. It's like 2 inches thick in a big, like school notebook size. So it's a lot of technical information when it comes to fire alarms. See you next week when we talk about the different fire protection systems. Much shorter lecture in that one. And don't forget to do any assignments or tasks associated with this module.